This is a supplemental lecture to week 4 of the Executive Black Belt class. This covers lean metrics. We're going to fly through this. This is just hopefully a quick tour of some of the lean metrics that are available. It's not exhaustive. There are many that are in here, such as inventory turns that are not covered. Many in here. This is just to give you an idea of some of the more important ones. So let's have at it. This starts on slide 16 in your book. This is slide 17. The objectives that we want to use to complete this module. When you finish this, you should be able to demonstrate and use Little's Law, something that we haven't talked about yet, but we will in this section, and explain the meaning and the value of takt time, or takt time, lead time, cycle time, exit rate, or throughput is another word for that, value-added ratio, roll throughput yield, and on-time deliveries. I believe that the things that you will find that are perhaps a little bit foreign to you are takt time, definitely one of these things that's kind of important. I'll put a little star by it, or maybe I'll underline it. There we go. Instead of crossing it off. And roll throughput yield, or RTY, is probably something that's going to be a little bit different to you. So we want to cover those in some detail. The others, I think, you'll get right away, and we will cover Little's Law. So first, takt time. So takt time, people talk about it a lot, and it's unfortunate that it has a name that we don't understand, but think about it. It's one of those words that actually sounds like what it is. Takt time, or tak, one of the reasons why it's you can say tak is because it's like the tick-tock of a clock. And in fact, it comes from the German word baton, which is basically, it's the pace. It keeps pace. In this case, we could think about the pace that something gets done. So in production-type environments, call centers, and manufacturing lines and stuff like that, it's a very, very useful concept. In non-production environments, it's still a useful concept, but it's perhaps not so evident all the time. Essentially, it's this. It's sometimes also called the customer demand rate. But what it really is you look at the amount that you actually have to get done. That could be like, I need to cover 2,000 phone calls in a day. Like, that's my expected service level that I'll need to cover. And then how much available production time do I have to do that? Maybe I have 6.5 hours and I have 20 people. Is that enough to be able to cover that? So that's essentially what takt time is. If you look at, let's go over an example. Suppose you typically handle a load of 100 service calls per day on average. If you have 45 minutes for breaks on an 8-hour shift, what is the takt time in minutes for this service? Okay, so in other words, we have to answer 100 service calls per day. That means that we have, if we have 8 minus 3/4 of an hour, that's 45 minutes, right? Times 60 minutes in an hour. And if we look at 100 units, that means every call we have to handle in 4 minutes, or we have. I'm sorry, it doesn't mean we have to handle everyone, but it means we have to average 4.35 minutes per unit. Okay. Now, if we had multiple people doing that, right? If we had multiple people handling that service call, those 100 service calls, we could get that down to, say, we had 2 people, it would be cut in half. Our takt time would be cut in half, so we'd be able to handle that many more. Okay? It essentially tells you how fast you can or you will be able to handle production. All right. So if we can, for example, if we match our cycle time, the time that we actually do meet production, with the takt time, which is the production that we need to make, like in the last one, the company needs to handle one phone call essentially every 4.35 minutes. Well, if we're not handling that, if a pace of production is less than that, is greater than that, then we've got problems. We'll have to have people on hold. We'll have dropped calls, things like that. But you can also think of Takt Time as working in, say, project management or IT, and using the same sort of thoughts. If you look at, for example, IT projects, if you want to complete, say, 20 in a quarter, and you're completing 6, that means you're not able to meet that customer demand. Pretty simple concept, actually. And Takt, again, can be put to any level that you want. We didn't have to say so many per month. You could break it down to so many per quarter. We could break it down to so many per month, or so many per week, or so many per day, or so many per hour. At some point, number of IT projects is not going to work for, say, number that we complete every minute. Well, it's probably going to be 0 most minutes, but it might work for every week, right? So it gives you an idea. If you're managing this, the IT system design change process, for example, if we need to do 20 in a quarter, that means we need to do 20 divided by 3 per month, right? So that's what, 6.5 or 6 1/3, and that means that every week we're going to be doing essentially 1.5. So if a few weeks have gone by and we haven't had any releases, we know we're a bit in trouble. Okay, let's move on to lead and cycle time, and these are, a lot of people use them interchangeably. What we're going to say in this section is essentially lead time is the average time it takes to complete an activity from start to finish, and that's more like elapsed time. So it doesn't matter how long it was delayed. It includes all the delays. An example might be customer order to customer delivery, whereas a cycle time is usually people talk about the amount of time it takes to complete the tasks. Now, that's not always true. Sometimes people talk about, as I said, cycle time and lead time interchangeably. Here's some examples and with some definitions that we're going to put in here as we cover Little's Law. So if we look at lead time, and in order to understand Little's Law, we'll need to understand lead time and work in progress and throughput and how all those things are related to each other. Little's Law is an equation that relates the three. Let's talk about what they are in an example. Lead time is the time it takes from the release of a product into a process until its completion, or from customer order to customer delivery. If we're talking about standing in line at a deli to get lunch, the lead time is the time that you enter the line until you take the first bite of the sandwich. Work in progress, I think we all know what that is. It's the product that's being created or is created and not yet served or not yet delivered. That's in the process. Okay, so in the deli example, the WIP is the number of lunch patrons, the number of customers ahead of you in the line and being served. And then finally, the exit rate or the throughput. The throughput is the process, or is the amount of stuff that gets through per unit time of a process. So in the deli example, it could be the number of people that are served per minute, or the number of people that are served per every 15 minutes, or per hour. Okay, so that's the throughput. Now, Little's Law actually relates all these three, and it states that lead time is equal to WIP divided by exit rate. So what's kind of cool about that, or remember, exit rate is throughput. What's kind of cool about that one is that it shows you that if you want to decrease your lead time, there's a couple of different things you can do. And there's really only a couple of things that you can do. You can either increase the rate of throughput, that is the amount of stuff that you get through per unit time, or decrease the amount of WIP that's in a section, or that's in the process. This is something that people don't often think of, that is to decrease the amount of WIP. If we decrease the amount of work in progress, we can very often decrease the amount of time that it takes to deliver to a customer. That's pretty key. That's a pretty key. That's a pretty key concept. Um, Exit rate. We already know. Hey, if we start to do things faster, yeah, we're going to get things done quicker. But very few people think in terms of, well, if we just eliminate all the junk that's in progress, right, we can actually start getting things to the customer quicker. But this is a truism. It works in all of these things. By the way, exit rate, very often the key to getting good exit rates or good throughput is to not have to rework a lot of things. So that often can get you better throughput. Here's an example of lead time in Little's Law. We have a sales department that completes 5 quotes per day. That's the ACR, or the throughput. ACR stands for average completion rate, which is also throughput, which is also exit rate. A lot of words meaning the same thing. On average, there are 22 quotes in various stages in the department. If we apply Little's Law, we can actually solve for the amount of time that it's going to take, on average, for somebody to get a sales quote. That's pretty interesting. And by the way, that's another alternative to measuring things from end to end. Measuring actually how long it takes is one way to do it, but another way to do it is to use Little's Law and to count how much stuff is finishing per day or per hour or per whatever, in this case per day, and then count how much stuff is in the process. And that'll tell us. Okay. I'm going to skip over this particular slide. I think we all understand the value of shorter lead time. I mean, it's better for the customers, and it increases customer satisfaction. But one of the things that that we don't often think of is it can really improve cash flow too. If we can move the customer through the process more quickly, we can often get our invoices paid more quickly as well. So we get money back into our system. Imagine, for example, a billing system. If we wait a significant amount of time before we're able to get out that bill, certainly, depending on the terms of that bill, usually 30 days or net 30, often net 60, we could be delaying, the payment by 10, 15 days, and that can be very, very significant. All right. So lots of stuff. All right, let me talk about one more thing I think you'll find is a little bit different, and that's roll throughput yield. Now, unlike takt time, lead time, and the Little's Law concepts, which are very, very sort of lean concepts that belong in lean rather than Six Sigma, roll throughput yield can be either. And it's because it's more of a quality measure, but it's often a shock. It has a tremendous amount of shock value. Here's what rolled throughput yield is. Rolled throughput yield is essentially the amount or the percentage that gets through a process without ever having to be reworked or scrapped. Okay? So, and very often, if you look at a process, its yield is so small, its rolled throughput yield is so small that the stuff that actually gets through without error, you'll find is actually a very low percentage. Here I've put here just a 5-step process, and a lot of times processes are much more complicated than this. Some of the steps are very, very good, 98%, 99%, 95%, 95%. In fact, the worst one is 89%, which isn't all that bad. But yet, if we look at the rolled throughput yield, this is only the stuff that gets through without having to be reworked and without having to be scrapped is 78%. So just in this 5-step process, it's gone from 100% to 78%, over 20% scrap or rework. So, and let me tell you that some processes that I looked at, one in particular at a healthcare insurer, we looked at the provider data load. So loading data from providers, from the docs, from the physicians, into the system. Their rolled throughput yield actually was 0. It was identically 0, but when we looked at second pass for a particular step, because they had one problem with a particular step was always causing error. If we looked at the second pass, it was only 7% for this whole process, not for just that one step, but for the whole process. 7% of the time, they were able to load things without a glitch. That's pretty low and pretty shocking. They were able, over the course of 9 months, to get that up to well over 50%. Tremendous savings, tremendous gains for everybody. All right, value-added ratio. Value-added ratio is essentially simply the ratio of time spent in the process that's value-added versus the total amount of time. And now this is lead time, okay? Just so that we know, it's not processing time, it's lead time. So it's fairly straightforward. Essentially, you look at all the data, all the time that in this process. And again, this is using lead time, so it's from customer order to customer delivery. So, for example, wait time, any process that waits for running, if the customer is in process, whether they're standing in line or they've ordered and they're waiting for their Amazon payment, that's non-value-added. So that would go in the non-value-added piece. Okay, very often, if you look at value-added time, the value-added ratio is very small compared to the total time. And in fact, at one time, the George Group was claiming, and this is not so long ago, a few years back, that lean companies, when they were labeling as lean companies, these are companies that are really good, are 20% value-added time. That's really good. Sometimes it's shocking when you look at a process what the value-added time is. One of the processes that I first looked at, which was at a consultancy, it was a delivery process of a report to a customer, was about 1% value-added time. Just shocking. We were able to get that up to basically 40% value-added time. With again, I mean, tremendous gains in terms of how we used our capacity, our abilities to turn around a report simply were improved greatly. Now, the problem with this is, of course, defining what is value-added and what is not. So we'll talk about this in terms of three different categories, what we'll call customer value-add, which is really just value-add. And then there's two different types of non-value-add. The stuff that you actually have to do, which is sometimes called value-enabling. Hate that term, but okay, there it is. We call it here business non-value-add, BNVA, and simply non-value-add, which is just waste. Okay? So business non-value-add, without getting into it too much because these are all on here, I'll go back one slide. Business non-value-add would be things like filling out certain, like in healthcare, it'd be having the customer sign get a HIPAA signature, presuming for the moment that the customer does not feel that's an added value, or the time it takes to ask the customer their date of birth. Again, not a value added, may be required, or the time that it takes for them to, anyway, for somebody to process some of that paperwork. Those would be business non-value add. Whereas the customer waiting to use the MRI because somebody else is in front of him is delay. That is pure waste to that customer. So that is non-value added time. There's no value that the customer is deriving from simply waiting to use the MRI if they're in the queue. All right, so let's just look at the few. The customer value add, there's some rules on here. Here's what I like to think. I mean, I was taught that if the customer would pay for it, then it's value add. But I don't think that that's helpful enough because, the customers really don't pay for, it's pretty hard to say that they would pay for any of our internal processing. So I like to talk about it a little bit differently, and that is if it transforms the product or service in a fundamental way that's necessary in order to bring that product to market, or that product or service to market, I mean. then it's value added. In here, the line that makes that lines up with is it adds customer valued information or characteristic to the service. Again, if it transforms the product or service in a way that is necessary for the sale of that product or of that service, or the delivery of that product or service, then it's value added. These tasks should not, of course, be eliminated. They should be optimized, made to deliver as well as possible in a minimum amount of time. The second, business non-value added, we talked about what those things are. The important thing is really this one. I'm going to star this. They all should be questioned. In fact, a lot of times we do steps because we think that we're still required to do it, and we're not. So it's very helpful to question those business required non-value added. Okay. Now, the idea here is to reduce those. So if we absolutely have to do them, we should do them with a minimal amount of cost and time, but we should question those. Then finally, non-value added. These are anything that fit into the 7 deadly wastes or the 8th waste. Usually that doesn't add non-value added time, but at least not immediately. But these are simply things that are wastes. Some examples would be any handling, inspecting, transporting, moving, counting, delaying, storing, rework loops, getting multiple signatures. All of those things are add to non-value added time. Okay? These things should be eliminated. So the idea is to optimize value add, reduce non-value add, business required non-value add, and eliminate non-value add. All right. I believe this is the last one that we'll look at, and that's on-time deliveries. You're probably used to this one. This is simply a measure. It's a binary measure on any specific order or product delivery. It's either a yes or no. So, for example, if I were delivering a truckload of food to Stop and Shop and I was supposed to be there at 11 a.m. and I got there at 11:15 a.m., that would be a no or a 0. Whereas if I got there at 10:45 a.m., that would be a yes or a 1. If I add up all, or if I aggregate all of my deliveries for a day, or for an hour, or for a shift, then I get a number, and that's usually a proportion of on-time deliveries. So if we look at on-time deliveries, generally speaking, we look at over whatever time unit we're looking, say a day or a month, we're looking at the units, the total units received on time by the customer, divided by the total units that were actually shipped. Now, just to mention this, sometimes it's measured at the line item level. So Amazon, for example, if you ordered 5 books, they may count 4 out of 5 you're on time if they ship 4 of the books to you and they let that 5th one slide. That may make sense. It may not. Generally speaking, I think you would want to err on on caution and count that as not an on-time delivery. But there could be exceptions to that. All right. On the final slide here, which is slide 34. Easier to read if I take off my my writer here. Yeah, slide 34. There's an exercise using lean metrics in a sales process. So the sales process that's shown to the right here, which is clearly in the decline. If we look at that decreasing slope, right? If we look at the decreasing slope, whoa, not looking so good. If you're the director of sales, you've got some explaining to do maybe. What I'd like you to do is to use the data that's in the file salesprocess.xls to determine a course of action. Okay, what would you do? Just at a very high level. Obviously, we're not going to say fire people or I'd sell a different product or whatever. But I want you to examine the exit rate and the WIP and to suggest a plan to get the sales process back on track. Okay? So That's going to be in your next assignment, and hopefully that will be a nice challenge. You'll be able to get to see some of these lean metrics at work. Okay? All right, so we covered a lot of things. We covered takt time, we covered lead time, we covered Little's Law, which is a relation between WIP and throughput and lead time, right? We covered rolled throughput yield, which is maybe a different concept for you that you've seen than you've seen before. Very, very helpful metric. We covered value-added time or value-added ratio, and finally we covered on-time delivery. Well, I hope you found this a little helpful. We went through fairly quickly. If you have any questions, don't hesitate to call, and we will see you. See you next time.